Okay, exponential curve. So let's say we have some data that's not quite so straight line, such as uh, movie theater prices. Okay, so let's say back in 1950, a price to movie cost 30 cents. And then in 1960, it had gone all the way up to 50 cents. And in 1970, it was up to a buck. In 1980, it was up to $2. In 1990, it was up to $4.50. Okay? So, what should the price be in 2000 and then in 2020 if it keeps following this pattern? Okay? So, just grab your graphing calculator and you put in the data. So, second it's stat, edit, and then clear out your list. So you're doing the same as what you did the other day. Boy, my calculator doesn't want to work very good. So we have 1950 1960, 1970, 1980. Maybe if I flip it out of tablet mode, it'll work better. 1980, 1990. In 1950, it was 30 cents. Then 60, it was 50 cents. A dollar, then $2, and then $4.50. Okay? So you got the data in there. Once the data is in there, then you go stat, calc, but you don't go for this time. You go all the way down to exponential regression, which is 0. Press enter. And then we're going to store the regression equation into y1 again. So vars, y vars, enter, enter, enter. And then calculate. Okay. It's a good R value, 0.997. Okay. So the equation comes out as this. Let's go like this. All right. So the equation is y equals 6.72 times 1.07 to the x power. Okay. If we graph that, oh, we got to go, I got to wait till it gets done graphing. We got to go zoom, stat, which is all the way down at 9, I think. And there we go. And it follows the exponential pattern really nicely. Okay. Now I want to see what the price was in 2000. So if I try to trace, I got 1950, 60, 70, 71, 72, 73. But if I try to go to 2000, I'm going to get an error, aren't I? Because my window isn't big enough. So I got to move my window over a little bit. So I got to change my window. See how my window ends at 1994? Let's make it end at 2024. Instead of the max being $5, let's make the max $20 and see what happens. See what happens with our graph. So up it goes. And zoom. So if we go trace and up arrow and go to the year 2000, if it follows that pattern, in the year 2000, it was $8.17, which is still, for the year 2000, not bad to go to the movies. But the problem is sometimes exponential functions get crazy. If we go to the year 2020, my exponential function has gone all the way up to $31.86. Which I don't know how many people would go pay $30 to go watch a movie in today's world. Okay? So this function may have gone up exponentially for the first 50 years or so of its existence, but then after that, it needed to have leveled off something before it makes sense. Okay? All right. So that's an exponential function. So that's the types of things that you'll be working with today. Okay? Do you want to see another one or are you good? What? All right. So let's take another one. So let's say that a car is depreciating. So when you buy it brand new, when it's 0 years old, it's $42,000. When it's 1 year old, it's $36,000. When it's 2 years old, it's 32. No. Yeah, 32,000. When it's 3 years old, it's 29,000. What will the price be when it's 4 years old? If it's an exponential function. Okay? So stat, calc, or stat, edit, gotta edit it. Up, clear, down, up, clear, down. So 0 years old, 1 year old, 2 year old, 3 year old. Can't do 4 because we don't know the number. 42,000, 36,000, 32,000, 29,000. So once you get your numbers into L1 and L2, it's stat, calc, then go to 0. And we're going to store the regression equation into y1. Once we hit enter, again, a really good R value, 994. It's a negative this time. So if we look at the graph, oh, I did it again. I got to go zoom 9. It doesn't look very exponential, but it's got a little bit of a curve to it. So if we trace, I go from point to point, so I got to get on my line. If I trace, I can slide on over. And if you just keep tracing over, the graph, oh, it won't move. I got to make my window bigger. I'll go to 5 years and $0. And if we trace and I go down arrow and I go to 4 years old, it's worth $25,313. Okay. So that's how to do exponential regressions. Okay. My equation, let's go to my equation once. Stat calc 0, enter. My equation would have been y equals 41,383.85 times 0.8844 to the x power. Okay, that's my equation. My R value is negative 0.995. Really good R value. Okay. All right. So, your assignment is on pages 694 to 695. We're doing 7 through 10, but on number 10, or 7 through 11, sorry, 7 through 11. And then on 10, you're doing part B and C. And then on 11, just do part, we'll do both parts of 11, I guess. But on 10, just do B and C, because we're not going to do, it's going to talk about plotting the log stuff. We're doing things on the calculator, so we don't have to worry about that. So 7 through 11, 7, 8, 9, 10, 11, 5 problems. But on 10, just do B and C. And 10, you'll notice there's a lot of data to put in. But hopefully you can understand that.